dear friends, I am Dr. Sharad working as an assistant professor, Department of Chemistry, KTHM College, Nasik. Today we see the SYBSc Analytical Chemistry paper first CH301. pH at various stages of titration of strong acid, strong base. We can see right now. So pH of titration of strong acid and strong base at various stages. Dear student, we all of you know that there are such a types of graphs, titration curve we have to plot pH versus ml of NaOH added. So at the start the pH of solution is 1. So it is 1. Why it is 1? Because we can take the burette in which NaOH, and in the conical flask we can take the 25 ml of 0.1 normal HCl solution. Okay, so that HCl solution having the pH 1. So theoretically it is happen. So we can calculate theoretically pH at the start. pH at the start. So at the starting, without adding NaOH, in the conical flask there is only 25 ml of HCl, and that HCl having the concentration 0.1 normal, 25 ml HCl without adding NaOH. So that concentration of that solution which is having 0.1, and if you can consider that in the conical flask there is only the HCl, that means there is only the presence of acid and in which the H plus ion is present. So for that H plus ion we can calculate the concentration of H plus ion is equal to 0.1 molar, because the concentration of this solution is 1 and that 0.1 is represented by using 10 raised to minus 1. And all of you know that the pH of solution is calculated by using this equation. The pH is equal to negative log of H plus ion concentration is equal to log of 1 upon H plus ion concentration is equal to log of 1 upon that H plus ion concentration, that is 10 raised to minus 1, and it is nothing but the log of 2 is equal to 1. So at the start the pH of solution is, pH of solution is 1. It is proved by theoretically. This is calculated and this is graphically. Next, there is 2 points. In a such a way that before equivalence point and after equivalence point. So what is meant by the equivalence point? Equivalence point is the point at which the acid and base are equal. But before equivalence point there is the excess of H plus ion, and after equivalence point there is the excess of OH minus ion. In the conical flask we can take the 25 ml of HCl, that means excess of H plus ion. When in that solution we have to add the 2 ml of NaOH. 2 ml of NaOH. What is the pH of that solution? So after adding 2 ml of 0.1 normal NaOH in the solution of 25 ml 0.1 normal HCl. What is the pH of that solution? So here there is only 2 ml of NaOH get react with the 2 ml of HCl. That means there is the 23 ml of HCl is unreacted, and that 23 ml of H plus ion is nothing but the concentration of H plus ion is larger. So that concentration of H plus ion is calculated by using the formula H plus ion concentration is equal to millimole of H plus divided by total volume in ml. So that H plus ion is calculated by subtracting the NaOH. That means the millimole of acid taken in that conical flask minus millimole of base added. That means in this conical flask how many ml of NaOH is added divided by total volume in ml. Total volume in ml. Here millimole of acid taken, that means 25 ml 0.1 normal HCl minus millimole of base added. That means here 2 ml 0.1 normal NaOH is added divided by 25 plus that 2 ml is equal to, that is 2.5 minus 0.2 divided by 27. By calculating this, 2.3 divided by 27, and by calculation we got the 8.5 into 10 raised to minus 2 molar. That is the concentration of that H plus ion. If we got the H plus ion concentration, from that H plus ion concentration we calculate the pH of that solution. That is pH is equal to negative log of H plus ion is equal to log of 1 upon H plus ion is equal to log of 1 upon that values 8.5 into 10 raised to minus 2 molar is equal to, the values come 1.07. This is the pH after adding 2 ml of NaOH. That means when 2 ml of NaOH is added, the point at which 1.07. At every point we can calculate the H plus ion concentration up to the equivalence point by using this formula. So this formula is most important for the calculation of H plus ion of strong acid, strong base titration. That means H plus ion is equal to millimole of H plus divided by total volume in ml, millimole of acid taken minus millimole of base added divided by total volume in ml. For example, if we can change the addition of this 2 replaced by 5 ml, what happened? The solution is same. The concentration of that H plus ion is equal to millimole of H plus divided by total volume, the millimole of acid taken minus millimole of base added. Here the term gets changed only this, and that term is 5 into 0.1, and here 5. The answer gets changed here 0.5, and here 30 ml, 2.5 divided by 30, and that answer get 6.67 into 10 raised to minus 2 molar. And by using the same, we can calculate the pH of that. Negative log of H plus ion is equal to log of 1 upon H plus ion is equal to log of 1 upon this term 6.67 into 10 raised to minus 2 is equal to 1.176 after addition of 5 ml. 1.176, that is the pH of solution. So up to the equivalence point, we can calculate each point or each ml of pH by using this equation, that is the H plus ion is equal to millimole of H plus divided by total volume in ml is equal to millimole of acid taken minus millimole of base added divided by total volume in ml. So before equivalence point, we can see the pH addition of 2 ml, 5 ml, such types of 10 ml, 20 up to the 25 ml. We go by using the H plus ion concentration. But at equivalence point, pH at equivalence point. So very first, what is meant by the equivalence point? So equivalence point is the point at which the quantities of that acid and base are equal. That point of titration is nothing but the equivalence point of that titration. So here equivalence point of this titration is proved, that is the 7. But theoretically we can calculate it by using the pH is equal to 1/2 pKw. So what is meant by that Kw? That Kw is nothing but the water constant at which is having the value 1 into 10 raised to minus 14. By using this, the pKw value comes 14, and from that the pH is equal to 1/2 into that 14 is equal to 7. That is proved. The equivalence point, the pH of the strong acid, strong base titration is 7. What happened before equivalence point and after equivalence point? Here we can see that this is the point at which the pH is 7. Here we have to observe that before equivalence point there is the OH minus ion concentration, and after equivalence point there is the OH minus ion concentration, H plus and OH minus ion concentration. So after equivalence point, this is the equivalence point, the pH of strong acid, strong base is 7, and we go towards the pH at after equivalence point. After equivalence point, what happened exactly before and after? Look at here. This is the conical flask. In that conical flask, when we have to add, first take the 25 ml of HCl. That means there is the HCl, H plus ion concentration. When we have to add the solution of NaOH, up to the addition of 25 ml, there is excess of that H plus ion. And here is the equivalence point, where the both quantities of that acid and base are equal, and that is the equivalence point. We got 7, and here in the titration we have to also see that the equivalence point is 7. But after equivalence point, there is excess of NaOH. There is excess of NaOH because there is no HCl is remaining for the interaction with that NaOH, because 25 ml of HCl get consumed with the 25 ml of NaOH, and there is after equivalence point there is presence of excess of NaOH. So that is the pH after equivalence point get changed, and here the excess of excess of OH minus ion concentration is present, and that excess of OH minus ion concentration we have to calculate it here. So after addition of 26 ml of 0.1 normal NaOH in the solution of 25 ml 0.1 normal HCl, the pH of solution is calculated by using this formula. The OH minus ion concentration is equal to millimole of OH minus divided by total volume in ml is equal to. So how to calculate that OH minus ion concentration? So OH minus ion concentration is given by using the formula millimole of alkali added, that means the base is added, minus millimole of acid taken, millimole of acid taken divided by total volume in ml. So in this case, the OH minus ion concentration is equal to millimole of alkali added. That means here we have to add the 26 ml. So 26 into 0.1, that is the millimole of alkali added, minus millimole of acid taken, that is 25 into 0.1, because it is already taken, divided by 26 plus 25, and we got the value, that is 2.6 minus 2.5 divided by 51, and from that 51 divided by 51, the values comes 1.96 into 10 raised to minus 3 molar. 10 raised to minus 3 molar. From this, we calculate the pOH here, not pH, because the OH minus ion here. So negative log of that OH minus ion is equal to log of 1 upon that OH minus ion is equal to log of 1 upon that values, that is 1.96 into 10 raised to minus 3. And from this, we got the pOH, that is 2.71. So this is the value from which we can calculate the pH, because here we calculate the pOH, not pH. Okay, so pH is nothing but pH plus pOH is equal to 14, and by using this equation we calculate the pH of solution. pH is equal to 14 minus pOH is equal to 14 minus 2.71, and from this we got the pH, that is 11.29. So pH of solution after adding 26 ml of 0.1 normal NaOH in the solution of 25 ml 0.1 normal HCl, the pH is 11.29. So 11.29, which can calculated or shown by using graph also here, that is more than 10. So 11.29, that is the pH of solution after adding 26 ml. Also we can add here 30 ml. What happened? 30 ml of NaOH. Here value get changed 30, here 3.0, and from this the value of after adding 30 ml we got the pH that is related to the 12, that is related to the 12 ml. Okay, so in this way we can calculate each point pH of strong acid strong base titration. So we can solve the problem which is asked in your examination, that is calculate the pH of solution after adding 2 ml, 5 ml, 10 ml of NaOH or HCl. So we can see this. We can see the titration curve of strong acid strong base and pH at various stages we have to calculate it. Depend on this topic, the one problem is asked like this. They calculate the pH of solution after adding 12.5 ml 0.1 normal NaOH to 25 ml 0.1 normal HCl in a titration. That means here we can calculate the pH of solution like pH at various stages. If you can consider this problem, here the 12.5 ml of NaOH is added. That means NaOH is having the quantity 12.5 and the solution which is in which it is added, that is the HCl, and which is having the 25 ml 0.1 normal. This is the type of titration, that is strong acid and strong base titration. Here NaOH is the strong base and HCl is the strong acid. From this we know that the 25 ml of HCl, that means there is larger amount of H plus ion. When it is added the 12.5 ml of NaOH, that means that 12.5 ml of H plus ion get consumed and there is remain presence of 12.5 ml of HCl, H plus ion concentration. So that H plus ion concentration here we can calculate, and from that H plus ion concentration we can calculate the pH of solution. So H plus ion concentration is nothing but the millimole of H plus divided by total volume in ml. That millimole of H plus ion is calculated again millimole of acid taken minus millimole of base added divided by total volume in ml. So here millimole of acid taken, that means acid which is having the 25 ml 0.1 normal, 25 into 0.1 normal minus millimole of base added, that is the NaOH which is having 12.5 into 0.1 divided by 25 plus 12.5, that is 2.5 minus 1.25 divided by 37, and from this 1.25 divided by 37. From this the values comes, that is 0.0334, and from this we can calculate the pH. All of you know that the pH is equal to negative log of H plus ion concentration is equal to log of that 1 upon H plus ion concentration is equal to log of that 0.0334, and from this we got the value, that is 1.476. So finally, pH is equal to 1.476. Therefore, the pH of solution after adding 12.5 ml 0.1 normal NaOH into the solution of 25 ml 0.1 normal HCl is 1.476. Similarly, we can calculate 12 ml, 20 ml, up to the 25 ml. But when it gets changed, that the 26 ml NaOH is added to the 25 ml of HCl, then here we can calculate the OH minus ion concentration. Student assignment on the topic titration of strong acid strong base curve. Question 1. Calculate the pH of solution after adding 20 ml of 0.1 normal NaOH to 25 ml of 0.1 normal HCl in a titration. Second problem, calculate the pH of solution after adding 30 ml of 0.1 normal NaOH to 25 ml 0.1 normal HCl in a titration. Third point, draw and explain titration curve of strong acid strong base. Fourth, bromothiamine blue is the best indicator for the strong acid strong base titration. Why? And last question, what is the equivalence point of strong acid strong base? What is the equivalence point of strong acid strong base titration? Recap. In which in the next lecture we can see the titration of strong acid and weak base and titration of weak acid and strong base.